Summarising data example 9. I'm going to look at parts A and B initially because they go quite well together. I'll do part C as a separate example because that's group data. So we're looking at finding the interquartile range of this set of data. You find the interquartile range in a very similar way to how you find the median. Just to introduce the symbols I'm going to use Q1 to mean the lower quartile, Q2 to mean the median, and Q3 to mean the upper quartile, and that tends to be what's used on the Edexcel S1 papers, so try and get used to those. So to find the interquartile range, we need to find the lower quartile, the upper quartile, and subtract them. So we start by doing not n over 2, because it's not a median, we're doing n over 4. So there are, I think, 11 numbers in this list. 11 over 4, and that works out to be 2.75. Now, that doesn't mean the answer is 2.75, it means we want the 2.75th value, and if you remember, we round it up, and so we're looking for the third value. Now, I need to write these numbers in order to make sure that I pick the correct one. So I'll write them in order up here. So I think we have 1, 2, 3, and 4. There isn't a 5, 6, 7, 8, 9, 10, 11, and 15. So the third value, in this case, coincidentally, is 3. Upper quartile, 3/4 of n, or 3n over 4, the item that's 3/4 of the way through the list. So it's 3 times 11, because you've got 11 items of data, over 4. And if you work that out, it comes to be 8.25. Now remember, we said earlier, we always round up using this rule of Edexcel's, which is on page 4. So we want the 9th item. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 9th item is 10. And so the interquartile range is Q3 minus Q1. That's 10 minus 3. So the interquartile range is 7. That doesn't tell us too much of itself, but if we had another set of data to compare it with, we'll be able to see which one had the biggest interquartile range. In other words, which one had data that was more spread out. Okay, so the interquartile range there is 7. Now we're going to look at one from a frequency table, and if you remember earlier on when we were working out the median, we did a cumulative frequency column, so always worth filling this in straight away at the beginning because that helps you see where the items of data lie. 83, and then we've got 95. So n is 95, we've got 95 items of data, but we're not going to write them out in a list. We're not going to write these out 17 times or 29 times each. We're going to use the table to help us work it out. So we've got n over 4, which is 95 over 4, and if we work that out, it comes out to be 23.75, which we round up to value number 24. Now, where is that? Well, there's 3 in the first interval, there's 3 35s. By the end of the second line here, we've got 20 items, and by the end of the third line, we've got 49 items. So item number 24 must have been on this row. It must have a value of 37. So that is the upper quartile. The lower quartile, sorry. Now we're going on to the upper quartile, 3n over 4. So it's 3 times 95 divided by 4, and if you work that out, it comes out to be 71.25. So again, we round up, and we're after the 72nd value. So if we go down, we've got 49 up to there, and by the end of the fourth row, we've got 83. So value 72 must have been somewhere on this line, and everything on this line is 38. So the interquartile range is 38 minus 37, which is 1. That tells us that this data is very closely grouped together because the upper quartile and the lower quartile are very, very close together. There's not much difference between them. So the data is very tightly packed around the middle. So a list of data and a frequency table are done very similarly. I'm going to do part C as a separate example because that's group data, and so we'll need interpolation for that one.